Hello, and welcome to our webinar, How to Reinvigorate Your Investment in SAP APO Forecasting. The odds of achieving successful outcomes when using enterprise demand management technology for supply chain planning are the same as the flip of a coin. Why? The programs are just too labor-intensive, and the engines are not fit for purpose. The odds improve when optimizers are added to increase the output from ERP systems like SAP and Oracle. On this webinar, we will share insights on the benefits of using an optimizer for SAP. Our presenters today are Brian Semple, Vice President of Healthcare at ToolsGroup, Lora Cecere, Founder of Supply Chain Insights, and Gerrott Faulkingham, Business Development at ToolsGroup.
The interesting thing for me is that most people don't realize that forecastability or forecast uncertainty has grown in the last decade. If we look at risk and we look at demand volatility, it is the big circle underneath economic uncertainty. So as we look at the ability to forecast, it's become more and more difficult. And one of the reasons is the long tail of the supply chain. And the products that are very high volume, which are in blue, is really where we designed the tools of the 1990s, which were designed with the theory that we had a normal distribution on forecasting. But as we move into the long tail, the level of predictability becomes much worse, and we have a tail that is a issue because it is not a normal distribution. In fact, this is a histogram of future demand, and so as we think about probabilistic approaches and the histogram and the probability of demand, we can't just think about demand as a single number. We need to think about it as a histogram and variability of demand, and we also need to think about localized assortment and aligning demand patterns. This is a slide from a client where they were looking at localized demand, and they were able to actually drive growth by 5% at local retailers by recognizing that aggregate demand did not answer the market. The aggregate demand looked very different, but by looking at the long tail of the supply chain and localized assortment, they were able to actually grow in the market. Now, in today's market, demand management success is like a flip of a coin. We see that most people think that demand management is very important, but only 44% feel that it's effective. And when we look at the processes of demand management coupled with horizontal processes, revenue management, S&OP, supplier development, you can see that there's a very low level of satisfaction. And one of the issues is the fact that we're operating on the long tail with unpredictable demand in a market that is unprecedented. Now, when we look at satisfaction, we find that the ERP expansionists, folks like SAP and Oracle, have a much lower satisfaction rate, and they also have a longer time for ROI. And one of the issues is that the engines within these tools are not as well developed for some of the demand patterns that we see in today's market. And so as we think about data inputs and we think about engines and we think about data outputs, we have the ability to separate the engines from the architecture and to look at planning master data, the data inputs, and redefining demand so that we can align the engines that make more sense. And unfortunately, many companies make the mistake of trying to get precise on imprecise numbers, and instead what we need to do is manage the demand flows. And the flows are really the patterns, the order frequency, the order quantity, the batch size, the type of demand, and the product build to execute a supply chain strategy. And the longer the tail, the more skewed the distribution, and life, unfortunately, for supply chain planner is not as easy as it used to be. So as we think about this and we think about the business pain of cross-functional alignment and the ability to use demand differently cross-functionally for these processes, we can't use spreadsheets, and on average, companies will use spreadsheets, and unfortunately this kind of demand pattern can't be used on spreadsheets. And unfortunately, a lot of companies are stuck with tools that don't allow them to really model the long tail. And what I encourage companies to do is to take history, 2 to 3 years of history, and to test their current technology to say, is it able to model the long tail, and test best-of-breed providers like ToolsGroup and say, are they giving a better answer? So as we think about demand, we've got to step back and say demand flows through the supply chain. It's a river. And as we look outside in at localized assortment, we've got more and more demand latency. And demand latency is the time to translate an order into the shelf takeaway to the company. And this demand latency with a long tail changes the order patterns. And we've got to align the engines with the flows, and the fit of the engine is a more significant factor to user satisfaction in our research than the purchase from the same vendor. And we've got to test and learn and focus on outcomes. Now, we've got a case study that we're going to go through now where a company actually took advantage of a different approach of an engine to address the long tail. So you want to go through this, and I'll run the slides for you.
Okay, thanks, Laura. So again, it's Brian Semple here. So apologies for the delay in starting, but also apologies for my colleague Adam Randall from Systogenics not being available. So I am the Vice President of Healthcare, and I actually used to be a customer of what was Systogenics when I worked in procurement and logistics for the UK National Health Service, and then back in 2012, when I went to work for ToolsGroup, Systogenics actually became a customer of mine. So we've worked together for many years in different forms. And Systogenics is now part of the world's largest wound care company called Acelity. They merged or were acquired in 2014. And Acelity supplies more than 20 million advanced wound dressings every month globally. So it's a very large part of the health economy. And their revenue in 2015, just a bit of background, was just under $2 billion. A very wide range of dressings and therapeutic devices, and that's actually become even greater since they merged with KCI. And I say we worked initially with Systogenics from 2012, but we're now, since 2014, we've been working with the KCI products as well, and have absorbed those into the same system. And the sort of product dynamics they've got some very high volume mature products, like shown in the blue area of the chart, which show a very specific type of demand flow, but they are continuing their innovation and introducing new products, new solutions, and they're also growing globally as well. So there's again an ongoing change in dynamics and the flows through their network. One of the other challenges they have is obviously in medical products and medical devices. You need to get regulatory approval in various different countries. You have individual hospitals and healthcare groups doing clinical trials, and so all of those have a major impact on timing and understanding when your products actually come to market. If you move to the next one, Laura, the global footprint then. Yeah, so the global footprint. Say again, it's a company that are distributing to probably well over 100 countries, but those countries all exhibit very different very different profiles. So the US, North America, Western Europe, very mature, serviced locally by their own sales organizations. And they get sort of fairly regular ordering, often directly by hospitals. So they're doing quite granular order management, and sometimes by distributors. You then go sort of other regions like the Middle East, Eastern Europe, Asia Pacific, where they work through distributors, and there obviously the order profile is very different. It's more variable, less frequent, much larger orders, and sometimes very irregular ordering patterns. And then thirdly, you've got some emerging markets which are often sold, and typically these would be in Africa and some countries maybe in Latin America, where products are sold in very large volumes, probably on a tender basis, and those tenders are often there's a lot of uncertainty. And talking to about uncertainty, that's probably the most uncertain area. You don't know necessarily where you're going to get the contract. You don't know when the contract's going to start. You don't know when the call-offs are going to come, and it does play havoc with any form of planning through your network. So if you just move to the next one, Laura, and just talk about some of the real sort of planning challenges that Systogenics and Acelity are facing. As I say, there's very dynamic demand flows. I've covered that in terms of the fast-moving products, the long tail, the mature, volatile and emerging markets, and then the ongoing new product innovation. And what they were trying to do is they've been trying for a number of years to manage that with some limited success. They pretty much used, they were at the time using SAP APO. They were using a lot of Excel. They found that was really the only way that they could actually manage some of the complexity in their business. They didn't really have any structured mechanism to capture sort of market intelligence from their various different sales organizations around the world, or from their distributors, and their planning team was always trying to second guess the commercial input, and obviously then also trying to come up with one number for finance. And the tools they had, as they were very cumbersome and very difficult to work with. And what that resulted in was a very long time scale to actually deliver a consensus forecast. Their planners were working overtime, a lot of times just copying and pasting, massaging various different numbers, and then really trying to get that information into a state where it could then be put back into their supply chain systems. So they really struggled to get input to their inventory and production plan, and that then meant that they had an ongoing struggle sometimes to meet some of the high service levels that were expected. If you just move to the next slide, Laura. So we engaged with them, say, early in 2012, and they looked at our tool set, and we ran a pilot, a proof of concept with them over a number of months, and we went live with that in sort of middle of 2013, and the way the system works is they still use SAP. That are at the time they used SAP, and it's probably worth saying that when they merged with KCI, they've now actually transitioned completely to an Oracle backbone, but it's effectively exactly the same concept. And the ToolsGroup solution, the demand planning solution, is pretty similar to identical to what it was before. So the way it works is that we get historical demand data every week. From SAP. We could take it every day, but they've chosen to bring it in weekly. We develop from that a statistical forecast that looks at demand variability, looks at all of the different combinations of markets, SKUs, breaks that down into a statistical forecast. We then get some additional input from their sales teams, from finance, so that we're making sure we're actually closing the gap between the forecast and the budget. We're bringing in some of their product information in terms of new product introduction, and then obviously, as I say, the regulatory side of things as well, where we're looking to get products approved in specific markets that allows them to be sold at volume. And from that, then we were able to generate a consensus forecast. Once we have the consensus forecast, then the S199 engine then produces an optimized inventory profile. They operate mainly through it's about 6 global distribution centers servicing different parts of the market, and so we set a dynamic safety stock and ideal target stock level for each of those SKUs at each of the distribution centers according to the service level required in each of those markets, and then we push that information back into SAP and now into Oracle, where they take care of the replenishment of their distribution centers and feeding that information back into production. And then the final slide I've got is really around the benefits. So what they've managed to achieve was quite a significant reduction in inventory levels, but at the same time increased the service levels. Obviously, working in the healthcare sector, it's already pretty high service levels, but we managed to increase that while reducing the level of inventory. But one of the most important things for them as an organisation was being able to improve the productivity of their planning team. They pretty much had 2 or 3 people working for at least a week to produce the initial forecast. They've now got 1 planner doing that effectively in a day. So we've got a big improvement there. And they've got some other benefits as well, more visibility. It's much more graphical and easier to use than they'd otherwise been used to. So hopefully that gives you a picture as to what we've done with that particular customer.
Yeah, it's a great case study. How did the business users convince the guys that they needed to try a different tool? Because a lot of times, you've got the issues of IT standardization. How did the team actually convince their leadership team to try something different?
Yeah, I think it was really they had looked at APO. They'd been working with certain parts of it in production and some of their inventory fulfillment. But when they looked to try, they tried to explain to them what it was they were trying to do. They were implementing sort of a global sales and operations planning process, and they basically made it clear to them what it was they needed to do. And with their increasingly diverse business, they really were able to convince them that without even with spending a lot of money probably on trying to configure APO, it wasn't going to give them the right answer. So in that case, it wasn't that difficult. They were I think quite insightful. I think some other organisations maybe try to stick to the SAP for maybe a little bit longer, and then probably spend a lot of money before they eventually give up. But it was quite an easy discussion with Sysogenics.
Because of business leadership, it sounds like, and the knowledge. Okay, well, let's shift gears.
Very much. Yeah.
Yeah, let's shift gears now. Let's talk a little bit about the ToolsGroup solution. Gerrott, are you ready to share?
Absolutely. So I'll talk a lot about traditional approaches and how that compares to a probabilistic demand model, but I want to set the stage conceptually first about what traditional models do and really don't do that your business is going to need moving forward. So traditional forecasting models right now are adequate at best at handling fast-moving items. But as you start to move down to the medium and slow-moving items, they cannot at all handle those types of items. And from a planner's perspective, it requires a deep understanding of statistics, or you need a PhD level education to correctly identify some kind of method or algorithm that works best for your business. So this results in a lot of high amount of touches to keep that model running to get you a valid forecast. Additionally, as items naturally go through their life cycle, they move from fast moving, and then as they start to phase out, they become more lumpy by nature. So planners have to manually switch between algorithms, and that's going to add a lot of forecast volatility into the given model itself, which is obviously not very good for the supply chain that has its own natural volatility in it already. The final point with fast moving items is that you cannot scale this with a company. So if you're using a traditional approach, or if you just stay back on the other slide there, as you're using a traditional approach, scaling from 100 items to 200 is not too bad, but as you start to move into the 10,000 and above range, the complexity is too strong, and it's very tough to model that. Traditional models also do not leverage existing data, so what they tend to do is aggregate the data upwards into monthly buckets, but you're losing that weekly or daily level granularity. You can't even leverage things like POS data or Nielsen or IRI data at that point as well. You're also at this point assuming that items have a normal distribution, which is just simply not true as you get to your slower movers. The final point is you cannot take advantage of any additional data streams. So anything that's stored outside of the system or in a business process, you lose the ability to model that with traditional models. If you go to the next slide, Laura. So as you know, the long tail itself is growing. On the left, you have those fast-moving, stable items, and then on the right, as you start to get into the more intermittent or lumpy items, that distribution of the demand truly changes. So if you're doing variability calculations on the left of the graph, traditional models will work, but as you start to get more and more lumpy with your demand, those distributions are going to change, and that forecasting model is not going to work. Next slide, please. So this results in reducing forecast error over time. With your traditional forecasting method, your forecast error over time as your variability increases drastically goes down. However, if you start to use more of a probabilistic approach outlined by the green method, your forecast error stays a little bit more true because you're understanding the true risk of how demand could occur. So how do we do an actual probabilistic demand model? If you could go to the next slide, please. It starts very similar to a traditional approach where you take a historical demand pattern, and if we layer on the next slide, Laura, you're generating a statistical forecast as a starting point. But as we build the next two slides, what starts to differ when you think about a probabilistic approach is we're not understanding that one number forecast, but we're also beginning to understand the range of demand as it could occur in terms of the lower bounds and the upper bounds themselves. So we have that one number forecast, but we also understand how low could demand occur and how high could demand occur, so we can start to use that in planning in the supply chain itself. Next slide, please. So in order to leverage your existing data, traditional approaches are going to use either monthly aggregations or weekly aggregations of shipment level information. But inside of your ERP system already, we have daily ship from information, we have daily ship to information, and potentially you have point of sale information. So that type of detail is traditionally getting lost in the old approach, where if you move to a probabilistic model, you can start to leverage that data. So the next set of slides will show you how we can actually leverage that data to improve our forecast. So let's set up an example. We have two different SKUs, SKU A and SKU B. In a traditional model, when we aggregate this demand up, they have the exact same aggregate historical sales. So if we build the next slide from a traditional approach, you would imagine they're going to have the exact same forecasting result. But the devil's really in the details here. If we build the next slide, the order patterns for these two items are vastly different. SKU A is ordered more frequently with less quantity, while as SKU B is ordered less frequently with more quantity. So they have different details about how that demand actually happens, which changes the forecast in a probabilistic model to start with. And if we build the next slide, what that's going to do is also change the certainty around that forecast. For SKU A, because there are smaller orders, if one order gets missed over the course of a month, it's not going to vastly change your forecasting profile. However, if one order for SKU B gets missed, you might miss 30 or 40% of your sales. So the certainty around that forecast is inherent in these details, and that gets captured in a probabilistic model that is not traditionally captured with an aggregated model. Next slide, please. So this is really just the starting point of how we think about a probabilistic model itself, and really a traditional approach starts on the base layer all the way down at the bottom of this slide with that probabilistic forecast. That's our starting point. Well, what we need to do to build an actual model is start to add in things like trend, seasonality, calendars, and then from there we need to begin to shape our demand, whether that's trade promotions, media effects, product lifecycle management, to actually give us some shape to that forecast. We know some signals of demand that have happened in the past. We can use that to explain the forecast in the future. And then as we start to move up the chart to points 6 and 7, that's starting to leverage machine learning and a lot of external data to really shape that probabilistic model to better explain what's going to happen in the future. If we could go to the next slide. So just to bring the point home, one of our clients, Wayfair, started with a traditional approach, and they were finding that their planners were having a lot of time managing their demand planning process. As you can see on the left, their program growth, or the amount of SKUs that they were going to be introducing, was going to explode exponentially over the next few years. And what they noticed is that their planners had a linear growth with that in terms of time spent as well. So before they implemented our solution, planners were on average spending the entire group itself about 100 hours per week. As they started to implement our solution, get used to the probabilistic model driving that forecast, their hours reduced from 100 down to about 17 per week, and that's as the business continued to expand. So they got a lot of time back to add value into the business to actually shape that forecast, and they spent a lot less time tuning the model itself. So the big question you should ask yourself right now is, why are companies still using that same traditional forecasting method that's been around for decades to solve the business problems of today? Thank you.
So let me ask you that question. Why are companies still using the same traditional forecasting methods that have been around for a decade? What are the barriers that you run into with clients?
I think it's because SAP is already there as a service, so it's very easy just to stick with the process that's been known. But again, that tends to have planners spending a lot of time messing with that system to get a value-added forecast, and again, it just doesn't scale moving forward.
So we have some questions from the audience that I want to spend a little bit of time on. Who normally takes ownership for the implementation of SO99? And how do the teams really organize? Is it a business user? Is it IT? What does the team normally look like?
Gotcha. So from ToolsGroup's standpoint, we have a project management team that consists of a project manager, generally a consultant or two, both functional and technical, and then a business analyst. That team within our group interfaces with our customers. So we have a project manager on the customer side that drives the project. But we're going to have to pull in some IT resource in the beginning of the project to do the initial data extract. And what's best practice for us is we like to build a core team with our customers that exist of current business users that really know the process and have a little bit of a technical background as well, so they can connect the dots between data and process moving forward. And those teams tend to work very well together to get these implementations rolling. To get a lot of value, as soon as 4 weeks into the process, we have a probabilistic forecast that's usually built on the demand side.
So there's a question by the audience. I think there's a misunderstanding. They're asking if on the probabilistic output, because I actually showed a histogram of what probabilistic analysis looks like. But on the output, what happens is you actually use some math or algorithm to actually translate it into numbers. And so there was a question about, are you dealing with histograms? Are you dealing with numbers on the output? Can you talk a little bit about how SO99 actually translates the probabilistic demand into a usable number?
Absolutely. So from the demand side, we still have the single number, which is, you could consider that being the forecast. The big difference is that's not necessarily the average. It could be skewed either way. And then from there, traditional methods will calculate some kind of COV factor typically. That's your demand variability, if you will. SO99 has a homegrown calculation that does this on the demand side, on the order line side, so frequency, and then on the average order size as well. So how big are my orders when they come in? So we're calculating all three of those forecasts, if you will, demand, frequency, and size, as well as the distribution around those three calculations. So those are essentially 6 numbers that we can then feed back into any system at that point, if that's what you'd like.
Right. That was the purpose of the question. Now, another question, and then we're going to wrap up here, is how frequently do you replace the engines on top of SAP APO DP, or actually just put your tool on top of APO or integrate into APO? Can you tell me a little bit about that landscape of deployments that you're experiencing?
Yeah, well, in terms of frequency, SAP is one of our top customers that we, as an ERP, we sit on top of. Could you expand a little bit more, Laura, what you're looking for, just to clarify?
Yeah, we don't know. It's a question from Jonathan, and Jonathan's looking for, do you replace the DP engine or do you replace the DP module?
Yes.
Or so we don't really know. So it's a question from Jonathan. Yeah.
Yeah, so yeah, we do. It's not only SAP, so we're ERP agnostic. We sit on top of any ERP system. Replacing the demand module is one option, but we have an end-to-end solution that we haven't talked about through this presentation as well. So we can also help replace inventory optimization functionality, as well as proposals or recommended orders. So again, for us, it's depending on what our customers need, we can feed back information in all kinds of different ways back into the ERP system to replace what's necessary for our customers.
Great. Well, thank you very much. That gets to all the questions that we've got in the question box. We will be sharing the slides, and we will be sharing all of the audio for this. We do have one more. Annalisa wants to know, how do you handle spike order patterns, considering the calculation? Is the technique okay for spike order patterns where you've got something that's a very responsive demand? Any feedback for Annalise before we close?
Yeah, so our system has recency bias, so typically when you see a spike in demand, there's a reason for it. If that spike is something that we want to forecast for, the system is going to pick up on that spike instantly as soon as we load new data. It'll affect the trend of the forecast and move forward. If that spike is something that's a one-time event, we use the probabilistic model to actually help planners look at exceptions. So that spike might potentially come up as an exception. You can then choose to either cleanse that demand history so that it doesn't affect the forecast, or keep it there so the forecast understands that there's an upward growing trend almost instantly when that data is loaded.
Well, thank you so much. Let's close. Is there one thought or, kind of, in your mind, something that you want to leave the audience with here today?
From my perspective, just going back to the layer slide in my mind, you don't need all of those additional layers that we're talking about. Really, what our engine does is come up with that probabilistic approach or model right on the base layer, and that probabilistic model, when we compare it to something like SAP APO, usually is a massive reduction in forecast error, as much as 20 or 30% reduction in some cases, just by building that probabilistic model. It's just kind of a nice to have to build the rest of those layers we were talking about, those seasonality, the promotions, the additional factors, the machine learning, etc. Those are all nice to haves, but the true nature is just building that probabilistic model to start when you compare it to traditional approaches.
Well, thank you very much for your time. I think back to the evolution of demand planning in the 1990s, where we had much higher volume. The demand wasn't as lumpy. We were actually working on regional supply chains with much smaller item masters. And as people think about demand today, I think most people haven't really analyzed either the increase in forecast error or the difficulty in forecastability or the impact of demand latency and lumpy demand. I'd encourage people to step back and say, is it time to do things differently? Am I in need of embracing the flows, and can I replace the engines and rethink the inputs to be able to drive better outcomes? Thank you very much for your time today, and this is Laura signing off. Thank you.
Thank you.